And this is a video on what's called the combined gas law. So it's just the mathematical procedure on how to solve problems. And here's what this is about. It's basically saying, okay, you have a gas that is at a certain volume. Okay, so maybe you have 500 milliliters of a gas. And it wants to know, okay, if we change the pressure and temperature, or if we have the gas at a certain pressure and temperature, like in this room, it's about 1 atmosphere pressure, about 300 degrees Kelvin. What happens if we change the temperature, or change the pressure, or change both? Now what's the new volume? Or we could even go, we have this gas in here at a certain temperature, pressure, and volume. What if I change the volume of the gas, put it in a different container? What temperature and pressure would it now be at to fit in that container? Okay, so remember, if one of these things changes, something else does. The thing we're not taking into account here is the number of moles of gas. So we're always saying the number of moles of gas is not changing in these problems. There's the same number of molecules on each side. So we're only changing pressure, temperature, and volume. The little 1 and the 2 don't mean a lot. I don't usually write that up there. But that just means initially, this pressure, temperature, and volume. If we change it to this, now what changed? Okay, so here's our initial, like our P1, V1. And here's our final. We're trying to figure out what's the new volume. So if you look here, our temperature is getting colder. So that should make the gas get a little bit smaller. Our pressure is going from 745 millimeters of mercury up to 760. That's increasing pressure, which pushes the molecules together a little bit closer also. So our gas should get smaller. It should be less than 100 milliliters when we're done here. So plug our numbers in here. It does not matter what things are in except for temperature has to be in Kelvin. Temperature's got to be in Kelvin. It doesn't matter if pressure's in millimeters of mercury, kilopascals, atmospheres. Doesn't matter what your volumes are, okay, as long as it's the same on both sides. Okay, you can't put in milliliters here and liters over here. Okay, it's got to be the same on both sides. But temperature has to be in Kelvin. So remember, degrees Celsius plus 273 is Kelvin. So here we have UV over T. We got 745. I'll put them in parentheses just to separate them out. Times 100 milliliters. So there's our P times our V over our temperature, 293 degrees Kelvin, which is about room temperature, pretty close to it, equals, all right, now we've changed the pressure to 760, so we put a 760 over here. We're trying to figure out what is the volume. It won't always be volume we're solving for when the temperature is now 280 degrees Kelvin. Here's your way to solve this. My suggestion is cross multiply and divide. So cross multiply where there's no variable. So diagonally, we're going to multiply where there's no variable, which requires you to multiply 3 numbers. So 745 times 100 times 280. And then you're going to divide by everything that's left over. So cross multiply and divide. Cross multiply these 3 numbers, divide by 293, divide by 760. That's the same thing as dividing by the product of those 2 numbers multiplied. But it's easiest just to type in this times this times this, divide by 293, divide by 760, it equals. Your volume there ends up being about 93.7 milliliters, which we said should go a little bit smaller. So 100 milliliters shrunk down a little bit because we changed the pressure and the temperature. I'll give you a couple more examples here. So next one, notice there's not as much information. Okay, it doesn't give you all the information last one did. It's only giving you temperature and volume. So pressure and moles of gas are not changing. Okay, pressure and moles of gas are staying the same. So if we look at this, we only have T and V. So since pressure is not changing, you could put a number in there for them that's the same on both sides, or just leave P out of it. So V over T equals V over T. So if something's not in there, that means it's staying the same. Now we set it up like this. So we have this volume, 200 liters, at a temperature of 25 degrees Celsius. Remember, we have to change that into Kelvin. So plus 273 equals 298 Kelvin. Equals, if we increase the temperature to 50 degrees Celsius, which is 273 plus 50 is 323. So our temperature is that temperature in Kelvin. What is our new volume? Well, think about this. It got hotter, so the gas should expand a little bit. Okay, it should take up a little bit more space. Those moles. Assuming the pressure didn't change, the number of moles. So again, we're going to cross multiply and divide. In this case, we only have to cross multiply 2 numbers. This times this, divide by everything that's left over. So always multiply where there's no variable. divide by that. Our volume ends up being about 216.8 liters. 1 decimal place is good for these problems. Again, it got a little bit bigger. It was 200 liters. It's now 217 liters almost because the temperature got hotter. Another example here. So this one gives you pressure and volume only. Pressure and volume. It's asking you for a pressure. So in this case, we only have pressure and volume. There's no temperature. Temperature is staying the same. So you could put a number in there. You could put a temperature here and temperature here and keep them the same. Or just ignore it, which means all you have is P times V equals P times V, which is an inverse proportion between those two things. PV, P times V equals P times V. So we have a gas at this number of kilopascals, which is basically pressure at sea level. So we go, okay, we have a gas at 101 kilopascals, and the volume is 20 liters. What pressure will the gas have if it's at 30 liters? Well, if a gas spreads out, it now has less pressure. Okay, that pressure had to go down a little bit for it to spread out. So we're going to multiply and divide by 30. Multiply these two numbers. We divide this by 30. Those cancel and divide this by 30. So multiply, divide. And our pressure there is about 67.3 kilopascals. So again, figure out what you're starting with, what you're finishing with, go from there. The only other thing I will tell you is STP means standard temperature and pressure. STP is standard temperature and pressure, which is 0 degrees Celsius, or 273 Kelvin, and 1 atmosphere of pressure. So if it says something's at standard temperature and pressure, that's 0 degrees Celsius, 1 atmosphere of pressure. 1 atmosphere, remember, is 760 millimeters of mercury. You'll have that conversion sheet. Thank you. Have a great day.